So we are Group 10, which is the GPS pattern acquisition team, and I am Daniel Thompson, and I worked on the data analysis portion.
I'm Billy Huggins, and I built the enclosure.
Ryan Daly, and I did data collection and motor control.
I am Hong Lin Zhai. I was doing the user interface and the 2D chart.
So the goal of our project was to develop a product that could help GPS antenna developers test the pattern of their antenna. The industry standard test right now is very expensive, and so our goal was to provide something that could give them feedback that they could keep around in the shop and test during the development phase. So our project has two main parts. So we have our data collection part, and to do that we use this device we have here. Right now you can see the test is running. What it does is it actually rotates the phone around in this orientation, and then it'll actually rotate the whole base around in this orientation. And the goal of this is to get as much coverage from as many satellites as possible. Over here we have our control reference receiver. This is a patch antenna. We use this to compare our values to our device under test, which is the cell phone. After the data collection is complete, we then run our software on our computer over here. This is a Python program that we wrote, and what this does is it takes the data files that were saved from the cell phone and the reference receiver, and it computes and analyzes the data. It produces both a 2D chart, shown here in the video, and a 3D chart here. What the sphere is basically, if you can picture a circle or a sphere around this cell phone, each section on the sphere represents a different area of the antenna. The color highlights how good the antenna is in that section, green being good and red being bad. As you can see here, the sphere has many positive and negative spots. This allows the antenna developer to then go back to the design of his antenna and decide if he wants to make changes in order to try and get better coverage in certain areas. So the hardest challenge of us was to try and get enough data in enough spots. As I mentioned earlier, the sphere around the ball, the goal is to try and get as much coverage. You can see there's some gray, which is data points that we weren't able to capture. The industry standard test, which costs about $10,000 to compute, does degree bins of 30 degrees by 30 degrees. So our test actually does 15 degrees by 15 degrees. So we were actually to get 4 times the magnitude. So our challenge to be able to do this was to figure out how to rotate the phone in order to get as much data coverage as possible. We approached this challenge by doing many test runs with both handmade rigs and by computing data analysis to see how those rigs would work out. We came to the conclusion that rotating the phone at 7.5 degrees would be the best alternative, and we were very pleased with our results, which we were able to get more accurately than the industry standard. We learned a lot about project management from our presentation. We had actually an exchange student from China in our group, so we had a lot to deal with just different language barriers and trying to communicate through different aspects. We also had to break up our project into different roles. So our project had a lot of different stuff, and we were able to separate things into 4 different sections that were able to, all 4 of us, streamline the process at the same time. So we had someone working on the enclosure, we had someone working on the data collection, we had someone working on the user interface, and I was working on the data analysis. Breaking up the task into these left us all to kind of fight on our own parts, and then when we brought it all together, it was a big integration process. So we definitely learned a lot about how to communicate with other people and how to bring things together.